Now in this lecture, we're going to be see how we can run the simulation. So in this session, we have seen that orientation, user need, system definition, detail losses, horizon, and the near shading. So after that, we're going to do the run the simulation. From that, we're going to generate the report over here. So we just click on the run simulation. So it will take a time, 30 seconds. It will going to be take on an average. It will going to prepare the graphs and the reports properly in the manner. So it has been created now. So we just click on the report button over here and we try to create the report for this particular residential scale standalone type of an project. So once we create the report will generated in terms of an PDF format. So there everything has been included in the particular report. So we just saved this particular report in terms of an PDF. We give the path of this particular data as in the where we have to select this particular data, and we just open this PDF now. Okay, so once it has been opened, we just open this particular PDF. We'll see what parameter has been included into the PDF or the final report has been generated. So now the project name also has been written over here with system that we are designing, where the location is, what is the system power is there, with a battery if we have taken, or any condition that we have changed with a simulant variant. Then it has been written that the project summary, where the site has been located, latitude, longitude, altitude, albedo, it has been written. Which meteor data that we have used, from which meteor data that we have used also, that is Meteor 8 or NASA database or PVGIS or Solcast database, it has been written. Thereafter system summary that we have, it consisting of the tilt angle, azimuth angle, near shading option, household consumption 8.6 kilowatt hour per day. Then the PV array has been written, that is a 12 number of a model we have used. Then what would be the battery packs are there, which battery we are using, total number of a battery, voltage of a battery bank, and capacity of a battery bank. Result summary is consisting of available energy falling on a solar panel, specific energy production, and you use energy, that is this much amount of energy per year created by the solar power plant. What is the performance ratio in that case, and what is the solar fraction receiving on the solar module. Thereafter, table of content consisting of all these parameters written one by one. We can see the first parameter, general parameter, consisting of what parameter we have learned, like the 3-dimension shading parameter we have seen, how many number of total shade that we have used, that is the 3 arrays we have used consisting of 4 solar panels. Then we have transposition model has been written over here, which model has been used for the simulation. Then there is a shading spacing width, then we have a ground coverage ratio, limit profile angle, everything has been written over here. Thereafter PV array characteristics in detail has been written, what is a model, PV model we have used, their classification, their number of a module, then the string sizes has been written over here, combination, their operating condition has been written, at 50 degree how much amount of the voltage and current will it be able to produce. Controller parameter has been written, which controller we have used. Thereafter what is the temperature coefficient of it, then the converter that we have used, what is the efficiency of that, total PV power that we have used, module area, and the cell area has been written. Similarly, the battery parameter also has been written, like a generic manufacturer we have used, how we are connecting the battery in the 3 parallel and 2 series manner. Discharging minimum SOC has been written, stored energy in the battery is 8.9 kilowatt hour. Then we have a battery management control, charging, then we have a corresponding SOC, discharging corresponding SOC. Array losses has been written, what is the soiling losses has been, we have considered thermal losses, DC wiring losses, mismatch losses, all that parameter. Thereafter, it has been written the sun path chart diagram, what parameter we have used while preparing the sun path chart diagram. At particular day, what is the positioning of the sun will be there, how much parameter will behind the plane that we have considered, and the sun path chart diagram for the specific dates has been written. Thereafter, whatever the figure that we have drawn in the near shading operation, 3D dimension, so that figure that also it will going to be imported into the report also, how we have prepared the report, what parameter that we have consisted, and what is the orientation and iso shading diagram it has been written, day wise basis. Thereafter, detail energy needs what we have given, that is how much equipment that we have, their number, power usage, energy production, and energy consumption basically, that has been written. Their hourly distribution also has been written over here in a report. Thereafter, main result is consisting of the system production. Available energy is how much, total use energy is how much, excess unused energy is how much, specific production performance ratio, solar fraction has been written. Thereafter, the graphs has been written here. Normalized production per kilowatt installed capacity. So here the various colors has been written, like unused energy, system losses, and the battery charging energy supplied to the user. So this yeah, red color has been written, that is the energy supplied to the user. When we see here solar fraction and the performance ratio graph has been written, so we can just analyze what is the performance of the overall system also. Thereafter, whatever the data that we have imported from the Meteo norm consisting of the GHI values monthly basis, then we have available energy, unused energy, miss energy, user energy created, or how much energy we are giving to the user monthly basis. It has been also been noted down over here. What is on an average yearly production? It has also been written over here. Thereafter, when we see the further loss diagram, it has been given. So how much amount of the energy that will going to be falling, and how the overall thing will going to be changing. Like say how the overall radiation losses are happening due to the IM losses, near shedding losses, soiling losses. Thereafter, in the PV also we have a DC losses, PV module losses, mismatch losses has been written. So this diagram has been given, and ultimately how much amount of energy is been given to the particular user. This much amount of the energy has been needed, and this much amount of the energy has been supplied to the user, consisting of all the loss factor, which is on an average as actual for the particular data site, we can say. Thereafter, daily input and output diagram has been given. So how much amount of global irradiance falling on a plate or the panel, what is the effective energy at the output of the array. So with respect to GHI, how much amount of the energy has been created, and it has been given at the end position. So there on an average graphical analysis has been given over here. So like that, up to the 10 pages, such a kind of a report that we can prepare for our standalone system, consisting of everything what we have been designed or what we have been used while designing this particular project.